Alright, I want to take a look now at a proof that involves parallel lines. So this one involves, given parallel lines, trying to prove a relationship between some angles. And again, the relationships that we're trying to prove are generally angles are congruent, angles add up to 180, supplementary, angles add up to 90, complementary. Those three equations seem to keep popping up continually throughout this course this year. So right now I'm looking at trying to prove two angles are equal to one another. We are given a set of parallel lines. Now we're going to use that. Now there's not a direct relationship between angle 1 and 4 in this case. So again, they're not corresponding, they're not alternate interior, makes the Z, not same side interior, makes that C shape. Corresponding, we said, makes the F shape. So now I got to get from 1 to 2, from 2 hopefully down to 3 or 4. So let's start with angle 1. If I look at angle 1 and angle 2 and I sort of trace over those angles, it makes the Z shape. What's true about angles that make the Z shape? Well, they're alternate interior angles. So in this case, I can say, hey, since I have a set of parallel lines imply alternate interior angles congruent. So that gets me from 1 to 2. Mark that off. Now I look at angle 2 and angle 3. You know, again, 2 to 4 would be nice, right? If I could go from 2 to 4, we'd be done. 2 to 4 is not one of the types of angles we talked about. They are a specific type. They're alternate exterior, but we're mainly dealing with the 3. Corresponding, alternate interior, and same side interior. So again, I can't go from 2 to 4, but if I look at 2 to 3, it makes the F shape. Is that the F or this way? I don't know which way I look at it on camera. But it's going to be that F shape one way or another. In this case, it's sort of upside down and facing the other way. But now I can say, all right, since C is parallel to D, these two angles correspond. If I chop this off and slit it down, angle 2 would be corresponding to one another. They'd be in the same position. So now I can say, hey, angle 2 equals angle 3. This is parallel lines imply corresponding angles congruent. 2 to 3, right? Now I look down here. Can I make a relationship between angle 3 and 4? Now specifically, when we talked about just two lines intersecting, we had vertical angles, made that X shape, and then we had a linear pair, made that Y shape when I looked at the two angles. Well, in this case, I got two lines that intersect, and it does make that X shape. So I can say, hey, angle 3 equals angle 4, and in this case, it's going to be vertical angles congruent. That's an actual vertical angles theorem. We proved that if two angles are vertical, they have to be equal to one another. Now I can look at 1 goes to 2, 2 goes to 3, 3 goes to 4. What can I do with these three equations? Well, I can either look at it as substitution. I could substitute angle 1 in place of that, substitute angle 4 in place of angle 3. That's going to give me angle 1 equals angle 4. But since I have this set up nicely, this one ends in angle 2, starts in angle 2. Ends in angle 3, starts with angle 3. This goes at 4. I can go right from the beginning to the end, right from the engine to the caboose, using the transitive property. So there's a simple proof dealing with how do I get from one angle to another using some of the things we talked about. Take a look at it in a second. Let's flip it around and let's look at how do we prove lines parallel.